Hello and welcome to the third part of our infamous snake programming expedition. So at the moment, if I just refresh and remind you what we did, we've got the snake moving, and at the moment it's moving 1 pixel per update, which is 60 times a second. The actual snake game doesn't really work like this, so what we're going to do today is we're going to break this game board up into a grid of cells, and we're going to get the snake to move on the cells. So we're going to start off with a game board. So let's board size equal 20. We'll have 20 cells across, and we need to have a size for these cells. Cell size. Now I've given them a cell size of 30, and I have worked this out. My whole screen is 600, so 600 divided by 20, that means each cell should be 30. Now ordinarily you would put some calculations in here, and if you wanted to make your screen bigger, this would automatically update and change. I've not done that because I'm leaving that as an exercise for you to develop your code, and if you want to achieve the higher grades. So I'm giving you the most basic implementation of this. I'm certainly not going to put all the tricks and things in it to make it much better at this stage. I'll probably will do I might make a more advanced version later when you're well on with your projects, to give you some ideas. So now we're looking at these cell sizes. We need to actually look at the snake, because the snake is in pixels at the moment. It's 300 pixels from the left and it's 300 pixels from the top. But now we want cells. So for it to be in the middle, it needs to be 10 cells from the left and 10 cells from the top. That will be the middle. 10 cells and 10 cells. Now at the moment, that will start off up here because we're drawing in pixels. So let's have a look at the draw function. So the draw function is here. What we want to do, well, the first thing we want to do is perhaps move this. So what I'm going to do is I'm going to cut that out. This is called refactoring, when you rearrange your code. So what I'm going to do, I'm going to create a draw snake function. So, and I'm going to paste that, oops, I've missed something out. I'm going to paste that code in here, and then I'm going to then go to my draw function, and I'm going to call that function draw snake here. So as it runs this draw loop, it will get to this line here, draw snake, and then it will come down to here, it will draw the snake, and then it will go back to the next line. So the advantage of doing it this way is it will keep the update loop cleaner and easier to understand. So we could have a function for clearing the screen, drawing the snake, updating the game, and it will be nice and clean and simple. And then when we want to do anything with drawing the snake, you know, any effects or anything, we can go to this function and it will just make your code much cleaner. So at the moment we're drawing it in pixels on the screen. We actually want to draw it in cells. So we need to times this by the cell size, times the cell size. So it's really fast, we'll deal with that in a minute. But essentially what this has done is, if the snake is 1 cell away from the edge and the cell size is 30, then it'll be 30 pixels. If it's 10 cells from the edge, So 10 times 30, it will be 300 pixels. The other issue is that the snake needs to be the same size as a cell for it to work. Otherwise it's going to be overlapping. Now, as you've noticed, it is really fast. I can't even find the snake. Where's it gone? Whoa, yeah, it's really nippy. I mean, playing it at that speed would be a challenge. So we need to slow the game down. So the way we're going to do this is we're going to have a frame counter to count the number of frames that are happening in the game. So we're going to do let frames equal 0. Frame. Let's have frame. Start at frame 0. And then in the draw loop, what we're going to do is we're going to say frame plus plus. And what this will do is it will count the frames every time. So it'll start at 0, then it'll go to 1, 2, 3, every time it draws. And we can use this to slow the game down. So we could say if frame is more than 8, so once it's counted 0, 2, 3, 4, 5, 6, 7, once it gets to more than 8, or more than 7 probably, yeah, let's try 8. Once it gets to more than 8, we're going to reset it back to 0. And then what we're going to do is we're going to update the game. So we're not updating the game every frame. We're only updating it every 8 frames. So this will have the effect of slowing snake down. Now I'm zoomed in, so it looks a bit jerky, but if I zoom out, it will look like it should do. So this will give us a much more natural sort of feel for snake. You could make this longer if you wanted, say 20 frames, and then your game will be slower. So it's up to you to find the speed you think is best for your game. Or maybe this number slowly decreases. Oops. So maybe it starts at 30, and as the game progresses, every time you collect an apple, the speed goes faster until it's really difficult. So that's a game mechanic that you could employ if you wanted to. So that's it for today. We'll come back and do some more work in another session. I think the next one we're going to add an apple that appears, and then after that we'll start building out the actual snake itself. So I'll see you in the next episode.